Hello everybody, this is Tom Land. Welcome to today's GreenChill Webinar, Data in the Driver's Seat, Leak Patterns in Observed Data and How It Can Help Reduce Emissions. Thank you for joining us today. As I said, my name is Tom Land. I've been working at EPA for over 20 years and have the honor of managing the GreenChill program amongst my other duties here, protecting the ozone layer and climate. Hopefully you have all dialed into 1-866-299-3188 or the number for international callers, which is on the screen, and you've used the code 202-343-9185 pound to connect. We use this way of connecting to the audio. It seems to work seamlessly with fewer technical complications and allows easy participation during Q&A. I have muted everyone's phone so we don't hear ambulances and vacuum cleaners and other things. To unmute your phone, hit #6, and we'll go over that again. So we're recording today's GreenChill webinar. The recording of today's webinar and all past webinars are made available to everyone on the GreenChill website under Events and Webinars. And if you want a copy of today's webinar slides, you can contact Alexis St. Juliana. Her email address is there. It's also in the chat box. So we hope to have time for question and answers at the end. During the presentation, you can submit your questions using the chat box in the bottom right-hand corner, that long white rectangle. And everybody will see them, and I will at the end read and moderate those questions. During the question and answer period, you can also raise your hand, and I will show you how, and you can unmute your phone with #6 and ask your question verbally. So another thing you can do during today's webinar is you can have a private chat with anybody who's participating. The presenters, the participants, me. Hover over their name, you'll see Start Private Chat, and that's a chat between the two of you. So as I said, in the bottom right-hand corner is a long white rectangle. If you put your cursor in that box and start typing and then hit enter, then it will show up and you can put your question forward for everybody to see. If you want to raise your hand, in the middle of the top of your screen is a little person raising their hand. If you click on that to raise your hand in the drop-down menu, window pops up, and I see that you've asked to ask a question verbally, and I'll give you the floor. So without further ado, I want to get right to the presenters. Today's speakers are Jason Ayers, who's worked for over 20 years helping supermarkets and other types of buildings manage their refrigeration systems and reduce leaks and energy use. He has worked in the UK and the US. And Jeff Rupert, he has also worked in commercial refrigeration for decades and has worked on construction and cost control, energy conservation, and reducing the amount of installed refrigeration or refrigerants in stores throughout North America. So without further ado, I turn over the presentation to Jason and Jeff.
Thank you, Tom, and welcome everyone to today's presentation. I'm Jason Ayers, and I'm co-hosting this with my colleague.
Yes, I'm Jeff Rupert, and I really appreciate the opportunity to speak to everyone. We have a lot of knowledge and a lot of information that we would love to share today, and we're going to do that. So we're really looking forward to this opportunity.
Thank you, Jeff. So where are we coming from? We've got over 3 billion measured samples of refrigerant leak detection, and this has been collected over 20 years from various leak detection detection systems installed throughout the retail sector. What we're going to present to you today is how you can use this data effectively within your organisations to help with troubleshooting and using this data to help reduce your refrigerant emissions. We talk about connected solutions, how you can bring that data centrally and how you can use that data effectively to manage your assets, and by assets we mean the people that are going to fix these. Looking at time-based signatures and how they can be used to help reduce your refrigerant emissions, and ultimately to drive down the usage of refrigerant across your estate. The advantages of leak detection are well known. A food retailer has many hats to wear, and refrigerant leaks touches many aspects of their organisation. Health and safety and local code compliance is one area. EPA, CARB and other regulatory legislations come into play. We have the environmental credentials, corporate social responsibility, and our stewardship for the environment is key. And ultimately, cost comes into that as well. How do we reduce our refrigerant emissions? How do we make our labour more effective? How do we reduce our stock loss and increase the profitability of the organisations that we serve? So where could you be on your refrigerant leak detection journey? The information that's shown in this chart here is just a frame for the audience that we've got here and represents actual retailers in our industry. What we're showing there is the refrigerant leakage rate. So hopefully those numbers may be familiar with you. What we're trying to do with connected solutions and the data that we're going to show you in terms of leaks and how they're generated is getting you down to best-in-class operation. As some of you that may not have even started your refrigerant journey yet and wondering where to go and how to get yourself there. People who may have leakage rates above 20%, they're looking at how they move forward. You might have already started down the journey, installed leak detection in some of your stores, taken on board a refrigerant tracking solution, and maybe starting to reduce your refrigerant emissions. There are further opportunities to get you down into the low levels and best in class for your organisation, bringing a connected solution together, bringing your refrigeration designs and contractors all on board, and also bringing the automated leak detection into a cloud connected solution and using that data to empower your team to be effective.
So first, we ask ourselves, why do refrigerant leaks occur? It's not complicated. It's very simple. In fact, why is your car not the same condition it was the day you bought it 5 years later? It's simply because over time, the effects of weather, temperature, pressure, expansion, they all lead to the system moving. It never stays in its original place. Things like vibration, support systems, everything that leads to an alteration of the original system is going to produce a wear point. Wherever a wear point is produced, it eventually is going to lead to a leak. We would love to avoid that situation, but it's physics, it's science, it's facts. Though we try and design the leaks out of a system, we're not 100% effective on that.
So what that makes is leaks do come and go and difficult to find, so using the data that's available will help drive down your refrigerant emissions. First of all, as well as the causes of leaks, is where the leaks occur. We've got analysis of over 3 billion measured data points in a retail food environment. And the deployment of a leak detection system is imperative to help reduce your emissions. Key areas within the supermarket, the refrigeration rack room, the compressor set, cold stores, evaporators, where there's change in temperature and vibration, and refrigerated display cases are all key areas which should be looked at for the deployment of fixed leak detection. And obviously the sensing locations as close to where those potential leak points are key. Historically, in the past, leak detection alarm levels have been in the hundreds to 200 parts per million. The technology that's available on the market now are looking down to 1 ppm, so really driving down and looking for those low, small, habitual leaks, and trying to find those, fix them to reduce refrigerant emissions. And what do we mean by connectivity? Hopefully the three areas that we've shown on the slide here is where you are on your journey. You might be the unconnected retailer, where you have systems deployed across your estate. They're operating effectively in their own environment, but the value, the data that's in those systems has yet to be extracted. They work great on their own, but nobody's really alerted to that information, and it can't be used proactively. You might have started on that journey and looked at connectivity, where you're utilising a building management system or refrigeration management system to bring that data to one point, and you're starting to manage those alarms. Those alarms, though, could be very simplistic: a bell, a whistle, or an SMS saying that you have a problem on site. They don't tell you what's going on. They're more a call to arms, and there's no time-based tracking intelligence. Where everybody's trying to look for is that holistic approach, and we call it the cloud-connected solution. This is to be able to look at an enterprise level across your business, look at the information that's available, remote diagnostics, and using time-weighted algorithms to make data actionable and utilising your resources effectively, especially on the resolution of refrigerant leaks.
So Jason, this is the fun part for us as a contractor. This has been a complete game changer on our end. In time, in the past, we have always received alarms, whether it be through a remote monitoring company, or if we received a direct call from the store itself, whether that be a manager or a facilities manager, and the message is typically this: we have a refrigeration alarm, or we have a refrigerant leak alarm. Well, as a technician, when you receive that call, being experienced in the field, you're immediately wondering, what is the validity of this type of call? Is it a real service call? Is it a blip? Is it a single occurrence? Is it a catastrophic leak? What type of event is this before we roll a truck down the street? Until you are managing data, until you have a visual printout of exactly what the system is doing or what the leak detection system is recording, you're really taking a guess. You're trying to work off of familiarity, what you know of the store. You're trying to collate that information with another type of alarm in the system. You're basically trying to validate, do we need to go? We all know the importance of reducing refrigerant emissions, but sometimes you go and you find nothing. This type of information and this means of notification is what has been the game changer. Not only does this type of information go to the technician, it can go to the end user, it can go to the technician's supervisor, it can go to anyone that you want on the list that can pull this up through their smart device and see exactly what's going on with the system and immediately determine how quickly you need to get there and how valid is the information. This notification system alone has surpassed the old methods of a phone call saying you have a simple alarm.
Fantastic, Jeff. So that's demonstrating the value of bringing the data out of the system and how you can use that proactively with your labour resources. The other area is being able to look at this at an enterprise level. As a retailer, you want to stand back and look at what's happening in your organisation, and refrigerant alarms and usage is key to that element. Through the cloud-connected services, you can do that. And what you want to do is utilise your resources and this data effectively to plan where your labour goes to reduce refrigerant leaks. So to be able to look, sort, which is your worst leaking store in terms of alarm events, is key. We use a measure called the leak index that normalises the site for alarms and pushes the problem stores to the top of the list, so that Jeff and contractors can prioritise their stores and labour and be proactive in their management.
And what separates this from a single store is this is very effective if you have a multi-site. If you were a multi-site retailer and you have more than one store, if you have 10, if you have 20, if you have 50, if you have 100, whatever that number is, you can manage the leak index and focus your efforts to improve your company as a full enterprise rather than be reactive location to location. This is true management software that really connects us as a contractor with the end user.
Fantastic. So with all this data that we're collecting, what have we found with actual refrigerant leaks and the alarm information? And this is what we're going to share with you through the rest of this presentation. A lot of you have got leak detection equipment there, but a lot of people say, well, it doesn't work, it's not effective, there's no alarms on the system where I turn up on site. Through the 3 billion events that we've looked at, we've been able to categorise them in 5 areas, and we're going to show you those examples over the next coming slides. The overnighter, what we term this is where leaks typically occur at night, usually a build-up in a walk-in cooler where the door is shut, and that small leak builds up over a period of time. But in the morning when the door is open, that refrigerant moves out and nobody can find the leak. The Volcano is more of your traditional leak pattern that builds up over a period of time into a major eruption. We're not saying it's a catastrophic event, because if the call to arms to fix that leak was sooner, we should reduce the refrigerant emissions. The Defroster, this is where leaks come and go based on a time interval that you can usually tie down to the defrosting of a coil on a refrigeration system. The Undercover, this is where time is required in utilising the data to help pinpoint leaks. They may not be in the area that the refrigerant leak detection system is saying it is, but it could be other areas like high-level pipework. And the Repeater is showing the value of why you have refrigerant leak detection installed and the connected data out the back of it. When a leak is fixed, you want it fixed first time. You don't want repeat alarms, and the data can help support that. So we're going to show you more of these examples of how they look visually and share that with you now. So just to frame what you're seeing on the screen at the moment, you're going to see this in the next slide decks. We have a graph showing on the left-hand side the ppm value as recorded on the refrigerant leak detector that's been moved centrally to our cloud-connected solution. And along the bottom of the chart, we'll have the period of time. Some of them will say days, some of them will say hours, to help frame the type of leak that we're looking at and the grouping that we put it in. So what we've got here is what we call the overnighter. And what you can see here is the rise and fall in the ppm values overnight when the cold store is shut around 11 p.m. at night and lowers down at 6 to 7 a.m. in the morning where staff come in. If you're a maintainer and looking for those leaks and going through during the day, a traditional engineer might not actually be able to find those leaks. It's having that visual representation really helps him identify when the leaks are occurring. You can see the alarm values that we're looking at here as well. We are driving down to the below 100 ppm for those response to alarms. And these types of graphs that we've got here and the levels that we're showing may not even show on temperature or refrigerant levels within the system. So we are looking at these habitual alarms that are occurring.
Yeah, that's true, Jason. The value of a visual graph to a maintainer is it's much more powerful than numbers. If you look on some stationary refrigeration leak detection equipment, you may see values of 0, 10, 15, 20, and then 0, 0, 0, et cetera, But the value of a visual graph is undeniable. And as a maintainer, the overnighter is a painful leak to find if you do not have some sort of history or visual information to be confident. Most preventative maintenance activities are performed during the day. And during the day is when those coolers are highly occupied. So you may walk into a refrigeration cooler or freezer with a remote leak detection device and pick up nothing. In which case you go through your procedure, cooler after cooler, and you leave and you may not return to site for another 30 days or quarterly, whatever your cycle is. However, when the maintainer who's responsible has this type of information, especially visual information, you can focus those efforts and you can tell the guys that are on site, I want you to dig deeper into that cooler. You may not pick it up while you're there, but as you can see, every night it reoccurs under low occupancy levels. That type of information forces you to get into the evaporator, remove the panels, and do a deeper dive into where those problems are. Without that, it's a bit of a hit or miss. We have many examples of things that occur at night, whether it be pressure, whether it be related to other types of leak examples that you'll see moving forward. Without the data during the day, you are somewhat helpless.
So here's another example of an overnighter. Again, these are all typically cold stores and walk-in assets where this occurs. And what we're trying to show here is if the call to arms and action was at the start of November and an engineer attended and utilised the data, we would have reduced the high refrigerant loss and the high alarms further along this chart. Really shows the power of the data that can be used to make your engineers more effective in their operation. And again, another example of the overnighter here. This is over 7 days. The ppm values, again, are very, very small. So they're not going to attribute anything for temperature alarms, refrigerant loss, or any capacity in the system. And this type of pattern could carry on for weeks and weeks and weeks before you'd get any other types of alarms on the system.
Viewing this data as a contractor and being familiar with the system, you can also correlate these types of leaks with what type of defrost that system may have. If this is a gas defrost system where pressure and temperature are going to increase very rapidly, you see nothing all day, but then you see these graphs at night, you would know this is related to a defrost or has a high chance of being related to a defrost condition. So again, it's another useful tool, seeing the visual graph, being able to assess the information very, very quickly. You can show up to site, force that system into defrost, and be confident that you're going to find something.
Fantastic. And you can see by the leak pattern here, as the night time goes on, the ppm values slowly get bigger and bigger as that very, very small leak builds up and up and up. The cold store door is open, the refrigerant dissipates out of it, and nobody is none the wiser. So our next examples are what we term the volcano. This is where a refrigerant leak occurs. It starts off small and if left uncontested will result in a major refrigerant emission.
Yeah, I think you'll see that, Jason. If you please move to the next slide.
Sure.
No one wants this event. I'm sure everyone online has experienced this, and it's a heartbreaker. It changes everything as far as the store concerns when you have a volcano effect. The key to volcano, not to be confused with a catastrophic instantaneous event, is if you look at the information, volcanoes are very preventable. As you can see that this alarm started, the information started accruing at 6 o'clock in the morning. By noon, it's getting worse. By 6 o'clock in the evening, it's getting, as you can see the development of the volcano effect. Early notification, and I can't stress it enough, the early notification through a smart device with a visual graph that shows a consistent part per million value confirms that it's not a blip, it's not a single occurrence, it's not an overnighter. This is a constant recording of event that has the potential to lead to something catastrophic. As you'll see with the other graphs with volcanoes, they are preventable. Again, I'm not trying to confuse them with a one-time instantaneous catastrophic event. If you can remove more than half of every volcano event that you have in your business, you're going to be much more successful.
Thank you, Jeff. And the whole aim of the low-level leak detection system, the early alarm and notification are down at the alert and alarm at 100 ppm, is so that somebody can attend site within an agreeable SLA of 4 to 6 hours. There will be a leak, they will fix it, there will be a refrigerant top-up, but that will be a very small refrigerant leak compared with what we've got coming up here. And also, once we're into this stage, we've got a bigger system performance. A connected rack system is going to have a number of other fixtures that are going to go out on temperature and alarm, and there's going to be a more catastrophic loss in terms of trade. This is over a 48-hour period. This is a refrigerated display case sense and point in a food retail environment. And what we've got here is that same chart again, but on another channel that's on the sales floor as well. So you can see how leaks move around in an area, and utilising the data to help triangulate and pinpoint those alarms. Again, the Volcano's this classic pattern of a leak starting and moving into a more catastrophic stage. The third example that we've got here is the defroster, which is a little bit similar to what we showed before. We've got plenty of examples where leaks come and go when a system goes into its defrost cycle, be it a refrigerated display case or walk-in cold box or cold store. You can see here we've got a 10-day chart with alarms coming and going.
So during the defrost cycle, one of the keys here is a leak can show itself only during the defrost cycle, depending on what type of defrost that is. Mechanical controls, that typically would not leak under 40 pounds of pressure, but under 150 pounds, they do leak. So what differentiates the defroster from the overnighter is it is strictly related to a condition within the system or a condition change.
And once you see this visually in a graphical format that's part of the concise information that's sent out, it empowers the engineer to be much more effective in their operation to find the leak. And here we have another example of the defroster. This is just over a 48-hour period. I'm sure as refrigeration engineers and experts out there, this will make perfect sense. You can see here the repeatability of that leak event that's coming and going. Again, we're at a very low ppm value here. No system performance issues here. But if you overlay it with the defrost cycle, the leak pattern makes perfect sense. When the coil goes on defrost, you get the high leak, and as it comes off defrost and that coil contracts, the leak dissipates and goes away. So seeing this here empowers the engineer when he turns up to site to be effective in his operation.
Again, I would like to emphasize the power of a visual graph. Comparing numbers, we do it, we're successful with it, but the power of a visual graph is all about speed. The human eye can assess a pattern very quickly. And we're looking at leak detection patterns, and that's truly what we're trying to identify as contractors, is we're trying to find the pattern and the value. And when you can visualize that, the earlier the better.
And here we have a final example of the defroster again. This is over a 16-day period. You can see this common pattern developing. The frequency in time, when you see it visually on the graph, starts to help paint the picture of what's happening on that system. This is over a 16-day window. Again, very small. This leak could go on and on until the next case clean or the statutory leak inspection. But having the fixed leak detection system with the connected solution and the data that's going out to notify that allows you to be much more proactive in identifying and reducing the refrigerant losses. The next group that we'd like to share with you, we call it the undercover. It means you've got to use your brain a little bit to help identify those leaks. The refrigerant leak detection system that's installed in there is covering all the critical areas for refrigerant leak points, refrigeration racks, walk-in cold stores, display cases. It's going to help you indicate what area it is, but it's not always in that area. Sometimes there could be something else within that vicinity that is the cause of the refrigerant leak. So it's using the data to help look outside the box to help find the refrigerant leak. The technology that's being used is very accurate as well, with infrared technology that's now become the norm out there. Bulk readings, etc., become less of a likelihood.
The other aspect of the undercover and having data is a retailer. You've put together a budget to maintain your facilities. Within maintaining that facility, you've deemed that quarterly leak inspections are what's best for you. Some would say monthly are what's best for them. As a maintainer, it may not be monthly, it may not be quarterly. If you're responsible for the refrigerant as part of your contract, you may find that these undercover leaks are diluted samples that are very large, and it's affecting your profitability of your contract. I don't want to make this all about money because we're trying to accomplish a greater goal here. But at the end, everyone has to be successful. Managing this data can change the frequency of your activities to say we're just not there yet. If you're receiving clean reports, monthly, quarterly is fine. But if you have very active, low-level reports, you may need to up your frequency.
And this example here was a great one where we worked with a refrigeration engineer. Ironically, you might all be shocked that a leak has been occurring for over a 5-month period. But to put that in perspective, this is 50 ppm, these readings are coming and going, and during no point during this period was there any system loss of refrigerant, any other areas that would indicate that there was a performance issue. And he found a very small leak on an EPR that caused that issue. Another example of the undercover, these are two sample points on a sales floor of a food retail environment. You can see that they both attribute a very similar pattern in terms of their alarm type and duration. One's in the produce area of a sales floor, one's in the frozen food area. But actually the leak wasn't in any of those two areas. It was actually in the main HVAC unit that was covering the whole sales floor. A leak in that area was blowing the refrigerant across the sales floor. But it was using the data and being able to triangulate and visualize that helped the engineer pinpoint exactly where that leak was. So it's looking outside the box sometimes and using the data and local knowledge to be effective. And here's another example, again, utilizing similar channels of coverage on the leak detection. These are two rack channels in a plant room, one's rack A, one's rack B. We've overlaid them together so you can see that refrigerant does move around, the flow in the rack room, and the refrigerants move from one rack to the other. But what it's helped is pinpoint where that leak is, and the engineer found the leak in the end, rectified it, and both the alarms on both those channels disappeared. Again, it shows the accuracy and of the leak detection system. Here we're down in the 30 parts per million, very, very low levels. This is changing the mindset of the refrigeration engineer to detect and hunt out refrigerant leaks. Time does need to be spent at this level to find the leaks, but once you find them at this level, the refrigerant emissions are going to fall dramatically.
Very much the same thing. Undercover, again, these are the low-lying leaks that it truly takes a little bit of time and a little bit of visualization to focus your efforts.
Fantastic. And then the final example that we've got in terms of our grouping of refrigerant leak styles and type is what we term the repeater. What we're saying here is there was a leak, it was rectified on site, and the alarm levels went away and it's recorded as such. Having the fixed refrigerant leak detection system installed and having the data connected, we can see here that alarms started to reoccur again. Without that data, we wouldn't have known that that was happening on site. This generated alarms, the engineer went back to site and fixed the leak effectively. The whole aim is to improve first time fix, reduce repeat return visits, and ultimately improve containment of refrigerant in the system.
You know, Jason, we classify the repeater into two categories. It could be a partial fix, which you thought you made the repair, but you truly didn't fix it 100%. and you have follow-up test methods and verification, but it comes back to haunt you. Or you didn't fix the right leak. In most cases, when a technician goes out to site, there's a high probability that there's more than one leak. And depending on the technician and the size of the leak that he identifies, there could be another. Does the technician continue on? Does he search for another leak? Is he going to fix the one he finds and be confident that that's it? Or is he not going to be confident and say, I know that there's more than just this one? Using this type of information, we can identify that after he left the site, it's reoccurring. You have to go back. There's obviously another leak in the system, and though you found one, there are others.
Fantastic. So there we have our sharing with you of the leak patterns that we have identified over the 3 billion events that we've brought back over the 10 years of operation. We put up 2 slides to finish with again, just to sort of help frame you of where do you think you are on your journey to reducing refrigerant usage. Hopefully this has maybe helped you on your next steps to reducing your refrigerant usage. And how can you be best in class?
Now, I know retailers in all 3 categories. And even the retailers that are at the green level or below 10%, when you have success, that's fantastic. But when you have measured success, it leads to bigger and better ideas. The retailers that I know that reside under 10% in the green area, when they have the value of this information, they're still not satisfied. 7.4 and 7.1 looks great, but measured against yourself, you will try to achieve 6.5 and 6 and lower and lower. That's the value of being able to look at this holistically.
Fantastic. And to finally finish off, again, a slide that we've showed before, ultimately we're trying to make you as retailers smarter to help lower your refrigerant emissions and extract the value that's stored in all those systems that you've got deployed across the site, empowering the people to be effective in their day-to-day operation and to make us more accountable in terms of our operation. And thank you very much for listening in today.
Yes, thank you.
Thank you very much, Jason and Jeff. That was wonderful. It's time for question and answers. And I am hoping that everybody has follow-up questions. One that was typed while you guys were presenting is whether you guys get false alarms from chemicals, cleaning chemicals. I've heard about off-gassing from
I'll try and answer that from a technical point of view of the refrigerant leak detection system. There's 2 types of sensing technology that people use for refrigerant detection system. There's the more expensive but more accurate infrared leak detection systems. These are the fixed systems that are much more accurate in detecting refrigerant leaks and much less cross-sensitive to some of the questions on there on the chemical side. Some other people have used semiconductor systems, which are a much more cost-effective solution to refrigerant leak detection, but they are used more for compliance purposes. They typically alarm above the 100 to 200 parts per million, so not great for low-level leak detection. And that type of sensing technology, the semiconductor, is also much more susceptible to cross-contamination from other chemicals that may be being used within the environment. So a lot of it is the sensing technology that's been deployed within the site.
So a logical question was the question I asked a follow-on. How many sensors does a store typically need to collect the type of information that you've been putting forward?
Okay, a typical supermarket, we would say 16 individual sensing points. And what I mean by that is, so each rack would be have its own individual sensor or channel of detection. So if you have 3 racks, that would be 3. You count up the number of walk-in cold stores and allocate a sensor or channel to each of those, so that could be anywhere between 2 to 8, so you're up to 11. And then we would recommend a number on the sales floor, and a lot of this depends on the size of your store, but to put a couple on the sales floor around the frozen food cases, the produce area, to help identify leaks that could be occurring in those areas, and triangulate those together. So 16 channels of coverage is pretty atypical of what you would have in a retail food supermarket.
And Tom, one of our retailers has done this in stages. And what they did was they implemented the stationary leak detection with 8 channels, depending on your budget and how far you want to get, what you have to get started with. They started with the highest probability of where leaks would occur. And then they started solving those solutions, and they started driving down their leak rate. And then by studying the data and studying the leak points and where leaks occurred, it was easily determined through cost-benefit analysis that at this time, let's expand the system to 12 or 16, and let's go after the sales floor. Because if 20% of our leaks were missing because we don't have detection in those areas, and that developed a project, and we expanded, and we drove that retailer down to the next level. So 16 is a great number. Certain retailers who want to start, get a program in place, and then expand upon it after they study the data, that's very effective also.
Thank you for that. I am going to ask the next question, and let's hope this is the slide. So the next question is, what is the percent occurrence of each type of leak? Actually, this is not the slide I was looking for.
Okay, so that's the 5 groupings of...
There we go.
Types got here. Okay. So to answer that is, we don't have that information to hand. We haven't gone through all those 5 billion and analysed them at that level. What we've done with looking at the data is trying to show how leaks occur, how do they come and go, dispel the myth that the leak is either there or not there. That's what we're trying to do with this analysis, is to educate the audience of leak patterns and utilising the systems that are deployed and the technology to be effective in that. So the answer to that is not at the moment.
Tom, I can elaborate a little bit, though, in that the percentage of leaks and how they occur are usually correlated with the facility. So if you have a brand new facility that was designed and installed and tested and started very well, the chances of having undercover or repeaters, they're slim. They don't occur right away. You can have a potential overnighter due to a system change, or you can have a defroster. But typically you don't see the volcanoes, undercovers, or repeaters because the facility is new. We'll say 1 to 5 years old. When you start to approach 5 to 10 years old, depending on how the preventative maintenance program was performed, if there's one at all, is when you start to see the other underlying leaks come into effect. If it's a hot gas defrost location, and there's not routine maintenance or inspection of receiver levels or monthly leak checks, then you'll start to see those. They all come with time. So I would say it's a bit of a moving target, and it's more facility specific.
So the next 2 questions are somewhat related. So I'm guessing that there's no algorithm or that allows an analysis of the graphs to help identify which type of leak and or identify what part of the store you would need.
I'm going to answer those the reverse way, if that's okay for you, Tom. First
yeah,
of all,
that makes sense.
Does the data identify what part of the store? The answer to that is yes. The refrigerant leak detection equipment that's installed and the data that we're gathering each channel or sensor of coverage. So we know if it's the rack, if it's the cold stores, if it's display cases. So we have that information at that level. So we can pull out very simply of all those alarms that we've generated at the different alarm levels, we could say, okay, how many of the a million alarms were attributed to rack channels. We could pull that out very quickly. So we do have that granularity of information, and that is very, very useful to help on the deployment of leak detection, understanding where leaks are and where you want to prioritise maybe leak inspection out the back of that. It's also very useful for looking at who you buy equipment from as well, and the efficacy of that equipment as well. You can compare rack manufacturers against one against the other. There's lots of other stuff that you can do with the data to help be proactive in your procurement. The other answer to that question, which is more looking at AI and where we're going in the future, the answer to that is not at the moment, but it's definitely on the cards. How leaks, the rate of change of looking at PPM values, looking at that rate of change, looking at the frequency of alarms and quiet periods between all alarms. We are looking at as our next generation of how we can empower more information to that engineer. At the moment we are giving them more information that they've had in the past. We're giving them where that leak is. Here's a graph that's attached to that so that they can go to site and effectively identify that. But what we want to do is to add another layer of that with the AI to give them of what it is, so they actually know what it is and make them much more effective in their operation.
You know, Tom, when you couple refrigerant leak detection with refrigerant tracking, you have a very powerful set of tools, and it can lead to the next new design of your new facility. You can remove components that have historically been a burden, historically things like certain types of hoses that do not last as long or aren't as durable as other types that have caused catastrophic events. The leak detection combined with tracking of the information can single out components that you should not use moving forward.
You just to finish off on that whole AI and graphs and the common points, this chart here or graphic you've got on the screen, Tom, is looking at a store-by-store basis of alarms over a year period. All those stores are hyperlinked, so if you click onto that, it will expand out where those alarms have occurred over each individual channel. So that data is there, and it is used by some retailers to be very proactive in their management of their refrigerant assets.
So I'm going to come back to this chart that's on the screen right now because I have a question about it. But let me read another question that came in, which is, how important is low-level leak detection for contractors, and could they perform their job as effectively with only gross-level leak detection, I guess? So comparing what you're presenting versus, I think, actually let's go to your
second. I think what that person is saying is the technology that's coming out now is below the 100 ppm. There's where gross leak detection is looking at a couple of sensors that are sensing over a wide area and high ppm values.
And that's exactly correct. The gross leak detection is going to correlate with how much refrigerant we put back in during each event. If we are only working off of gross leak detection, I would say the average refrigerant leak is around 100 to 125 pounds. And that would be the average. If you want to reduce your leak rate, or I'm sorry, if you want to reduce the amount of refrigerant you're putting back into your system during your leak events, if you want to get down to the 50 pound or the 70 pound, 75 pound mark, you're not going to be able to achieve that just responding to large leak events or minimal coverage. You have to find the small, underlying, undercover, slow repeater type leaks that are, if there's multiple ones of those occurring at the same location, you will never achieve those low levels if you're not chasing low part per million.
So let me go back to this chart and ask one question that occurred to me, which was, and use the pointer because I have that ability. I'm curious why this one is referred to the maintainer instead of this one, which has a higher percentage of the charge, I assume, being lost. And you have others
I'll try
that
and create a story to that. So the green side and the status that you just showed there, which is compliant and referred maintainer, is to do with refrigerant usage. So that's what's been added to the system. So this chart is bringing together two really powerful bits of information. The leak event or the leak detection alarms on the left-hand side and actual usage on the right-hand side. The status is referred to maintainer as part of our refrigerant tracking software that even though that leakage rate could be 21% across the store, there may be an asset underneath that, because you can't see that, that has that's breached a certain level for compliance purposes.
got it.
So yes, hopefully that's given a little bit of that. It's the rules that we apply to help reduce refrigerant usage.
So it's really just two different data sets all in the same table. And
yeah, because ultimately you're trying to reduce your refrigerant usage, and refrigerant leak alarms should follow suit in some way or another. You should have the alarms, and then you should have the usage afterwards out the back of that. So correlating those two bits of information together, where we provide a refrigerant management solution that does that is really powerful for a retailer at an enterprise level.
And going
there's
back,
also a level of verification that takes place. If
right.
we have a store like number 53 that does have a higher percentage of the charge, but it's been completely verified, it's been double checked, it's been confirmed that it was a catastrophic event. It was unfortunate of the amount of refrigerant that it lost, but we've confirmed that we've isolated it and repaired it. Whereas the one above may be still in that state where, well, we believe we fixed it, but we haven't 100% confirmed that we've solved the problem. And in that case, you want to send a referral out to the contractor so that we follow up and we don't have another, we'll say, volcano event.
Right. I assume that you could also use this data to help identify which stores you would put into a schedule for retrofitting or remodeling.
Yes, exactly. You've hit the nail on the head. The data is hugely important from an engineering team in a food retail environment. Tracking refrigerant from a compliance point of view, Tom, and EPA is one thing, but it's identifying which assets use the most refrigerant, which has the most alarms. They're the things that they can build into their capital replacement programs. They have the quantified data that supports that. Is there a certain channel that's leaking all the time? Okay, yeah, we can repair it all the time, but ultimately we need to look at replacing that, and the leak detection data supports that in terms of their business case. So it's a hugely powerful tool from an engineering point of view.
Right, and it comes back to Jeff's point about with knowledge of the components in the different stores, you can say, oh, there's a pattern here. The store with X component seems to be all those stores that have that component are bad actors, and we need to address that.
That's certainly a useful thing as well, and also the age-old adage, as equipment ages, it does unfortunately leak more. So having this type of analysis to help stay on top of that is crucial as well.
Mm-hmm. Does anybody else have other questions? We have a very short amount of time for a quick question. If you want to verbally ask your question, hit #6 and unmute yourself, and you can ask your question. If you don't have any questions, I do not have any more, and I really want to thank you, Jason and Jeff, for a wonderful presentation. Let me go to the last slide again, just so everybody has your contact information. You can get the slides from Alexis, and we have recorded today's GreenChill webinar, and we will post it on the GreenChill website. Thank you again, Jeff and Jason. Wonderful, wonderful information. I hope everybody takes advantage of what they've learned today.
It was our pleasure, Tom. Thank you very much.
Thank you.
Thank you, everybody, for participating, and see you at the next GreenChill webinar.
The leader has disconnected.